Hey there, my name is Rohit Kumar, and today we are going to discuss a very important industrial concept that is Industry 4.0. So let's start. I hope you can see this basic figure, and this shows the progression from Industry 1.0 to Industry 4.0. So as you can see that in the end of 18th century, means there was a term called Industry 1.0, and it was totally mechanized concept. So mechanized concept means most of the things were mechanized, and that's why people used to do every activity, everything mechanically, and there was a lot of dependency on human labor, and raw cost was very high. But as you can see that in the second stage of industrial revolution, here in the 20th century, the electrification came into picture. And that's why the assembly line got introduced and the production system became kind of fast. So that's why the production and the labor cost went down. Some people do also say that the labors were cut off. So in this way, the people became unemployed. But that's a different issue because every time when some technology progression happens, then obviously the usual workers go out, some new workers come in, and that's why we do need to equip ourselves with new technology time to time. In the third stage, as you can see that Industry 3.0 means automation came into picture. Automation brought a very huge improvement in industries. And as we do know that when the things are automatic, means you don't need to worry about the production system when once you have set up the whole assembly line and it is going to function in its automated behavior. So point is that industrial revolution, the actual industrial revolution that is termed as 60s 70s period only, and as we do know that in this different sorts of robotic equipments, robotic arms were used to set up the functional behavior of different industries, and not any single domain, multiple domains got benefited by this, and so many workers went jobless. And again there was a huge crisis that industry is making people jobless, means industrial progression is not good for people. So I think it was a quite debated issue, but still I think that it's not the issue that technology is making people jobless. It's kind of thing that people are getting jobless because they are not ready to learn new things, or in multiple cases it's also not the condition for people to learn new things because of their physical reasons, because of their economic reasons. But still it's always not good to say that technology is the reason of unemployment, because if technology is the reason, then why people are not unemployed in foreign countries? So we need to go to the actual root conditions, and that's a quite long issue to debate over, and that's why I'm going to skip it. But in short, we should focus on our multiple population issues and the ability to learn a new skill issues. Then moving forward, it is the Industry 4.0, where we do discuss the concept of cyber physical system, and it is going to be a major change from Industry 3.2. So what are the changes? Let me introduce one by one. As we can see that there are different kind of notations. Here you can see that if we want to have a blueprint kind of thing for Industry 4.0, then you can see that people are supposed to put some sort of strategy for their industrial development. So you need to put some sort of a strategy. There will be some kind of business opportunity, and then business meets technology, where it is going to implement, means it is going to uh, take the benefits of technology into its implementation. And then some of the proof of the concepts are going to get implemented in terms of pilot projects. Then the learning period comes into, and where you evaluate and review the undergoing process. And if it meets your strategy or kind of expectation, then you are going to continue, else you are going to again change your the previous strategy. So point is that every time you are going to move into this circle, but every time you are going to give some new sort of inputs at this particular stage, because every time you are going to change your strategy, your opportunities, pilot projects, your learning, as well as your expectations are going to get different. So in this way, what I'm going to say that ultimately this cycle means in any industrial production system, there is a sort of cycle, but in that cycle, you are going to change some of the parameters, and then it is going to change the whole production process. So when we say that what is so different with respect to your industry 4.0, then industry 4.0 is not something very new thing. It is kind of a general thing only, and there are so many factors which are the kind of key components of this particular thing. So if I want to show you here, then you can see uh, means so many researchers have already worked on this sort of things, and so many research papers are out there. So you can go to Google Scholar also and you can search there. But in short, if you want to say that what are the kind of characteristics or the what are the key components, which are the key technologies, then these are some of the domains. Additionally, you can find some other papers and the numerous other figures where you can discuss a debate about the key technologies or the characteristics of industry 4.0. But let's see here, it is like big data. Okay, so big data is obviously major technology that is going to get used in industry 4.0, because as we do know that nowadays so many mobile devices and different sorts of devices are there in the market. People are using 4455 IP devices, and they are generating data at very rapid rate. So point is that so much data is being generated every day, and that's why this huge data is supposed to get mined at industry level. It might be some LAN level analysis, it might be some cloud level analysis or sort of. But ultimately, if you don't mine that data, how you are going to get the heuristics out of that data? So most of the social networking companies, because they are totally dependent on data only, ultimately they are going to mine your data, and then they are going to offer some sort of benefits or some sort of recommendations or some sort of product uh, priorities or some sort of suggestions for you. So in this way, big data is going to play a very big role. Secondly, simulation, because everything is supposed to be simulated, because without proper simulation you are not going to show that how the things are going to get converted into a final product. But as we do know that the physical process is time consuming, as well as from financial point of view it is a kind of burden. So it's always better to check some product or process in its simulation form before going into the actual physical process. So that's why simulation is going to be very key component of industry 4.0. Internet of services, so many different services are going to get involved into industry 4.0, because industry 4.0 is not a small concept, it's a big ecosystem in which so many technologies are going to get involved. Like there was another term, cyber physical system, with respect to kind of similar to industry 4.0. So there are two layers mainly, cyber layer and the physical layer. Physical layer means where all the physical components or the sensors or the devices are there. And when these devices are generating data and interacting with the numerous APIs to each other, then they are transmitting their data to cloud or some centralized server. There you are again employing different kind of mining, analysis, learning, etc. So many deep learning, machine learning, data analytics, big data management, so many technologies are going to get implemented at server or the cloud level. So all these components, the cyber and the physical component, this cloud component is totally cyber component, because that is in space, and being virtual, it is implementing. But ultimately, you need to provide services to users which are using the physical service, physical devices. So in this way, the cyber layer is interacting with physical layer, and physical layer is interacting with cyber layer. So cyber physical system is a kind of two-layer ecosystem, but these two layers are very big. So in these two layers there are different kind of services, there are different kind of devices. So industry 4.0 is also kind of similar concept, where you can see that there are so many services which are kind of internet services. Then the concept of augmented reality, to give user a better experience, you can offer the augmented reality concept, where they can have the AR VR concept and they can enhance their experience. Then cyber physical systems, where, as I told you, that cyber physical system kind of similar concept to industry 4.0, but not exactly the same concept, because industry 4.0 is kind of bigger ecosystem, and cyber system physical system is a kind of a smaller ecosystem that is going to get fit into the industry 4.0 ecosystem concept. Then the additive manufacturing means where the value of manufacturing is going to get enhanced or evolved over the period of time. Like we have the 3D printing. kind of concept. So 3D printing is going to help you, means build the basic prototypes very fast. So in this way, 3D modeling, 3D printing is going to enhance the user experience as well as visualization. So in this way, industries are going to get helped by additive manufacturing concept. Then Internet of Things, what are the things? Things are kind of small devices where they are supposed to, means like of basic sensors in your, might be in your shoe, in your sports watch, in your kind of necklace, might be some heartbeat sensor. So in this way, so many sensors and the small devices which don't have much memory or the power components. So in this way, they are supposed to get scattered over vast space, and they are supposed to generate data, so that that data is supposed to get utilized at some cloud layer. So point is that Internet of Things tries to connect all these things, means very small devices, and then whatever is the network, that is called Internet of Things. So in this way, industry 4.0 is supposed to get helped by IoT, because in industry there are so many sensors which are supposed to get distributed over the space, and each machine is going to have so many different sensors, and those sensors will generate one kind of data. Then that data is supposed to get passed on to the second machine, where the other type of sensors are going to enhance or influence the functional behavior or the data of generated by the first kind of sensors. And in this way, this cascading kind of chain is supposed to be there, and at the final level, your means some machine is going to get generate the final data. So in this way, your machine or the your supply chain is supposed to, means sorry, assembly chain is supposed to produce some kind of final data that is supposed to be the final output. So that is the concept of Internet of Things. And finally, cloud computing. Cloud computing is obviously very much powerful, because ultimately all the big computational things are supposed to get implemented at cloud level only, and it is going to reduce the burden at user side. And obviously, in case of Internet of Things, you cannot perform heavy activities at small things, because they don't have the memory capabilities and are very power sensitive. And finally, the concept of autonomous robots. Autonomous robots means the self-realized robots, means that they do have some kind of cognition inside themselves, and they do perform the activities based on the priorly coded system. So in this way, kind of expert system, you can say, and they perform their duties very well without getting tired and everything. So in this way, Industry 4.0 is dependent on these some of the few key technologies, and in some way we can also say that these are the characteristics of Industry 4.0. Okay. Now moving forward, that when we say that Industry 4.0 is the revolutionary thing, then it is going to change the future. Then what it refers to? So it refers to the convergence and application of some of the digital industrial technology. And I have already talked about these technologies. And earlier I talked about individually in about each of or the most of these categories. But in this figure, they said that it is the convergence, and it's completely true, because one technology is not going to get worked individually. It always takes into combination of multiple technologies. It takes help from one technology, gives help to other technology. And if you want to take a simple example, okay, so you are chatting with somebody. So you are chatting, then you are using a mobile device. So first thing, that mobile technology is here. Okay, so mobile level, you are using mobile technology. Then inside it, there is an Android or kind of some dedicated OS. So you can say that there are a lot more technologies inside this mobile equipment only. But let's say only mobile technology to this combination of all technologies. Okay, so that mobile device is mobile technology. Then you are using internet. So then there are some APIs. Those are governing your communication with your internet server. Then you are reaching at server level. Then at server level, there are multiple technologies which are handling the things at server level. So server management, and then security means there might be some key certificates. Those are taking care of your session going privately, and all the communication is secure. And then the user management at the server, then the communication management, then different sorts of protocols those the users are using. And then at user level, again, the similar sort of thing. The same mobile environment is also there, or there might be some wired LAN, there might be some other kind of devices, those are getting used, or there might be some dedicated private networks. So many things are there. And at network level, there are so many protocols which are going to get governed. So in this way, ultimately, any application, not only this mobile communication kind of example that I gave, any application that is being implemented in today's technological era is not using a single technology. It is ultimately using a combo of technologies. Means it is a kind of convergence. And then multiple applications are using to use those technologies in a converged way. And ultimately, when we say converged, means multiple things are going to get merged at a single point. But it might be a kind of means I don't say that those are getting to get used at only single point, because when you use some kind of technology, you use some technology at one point, other technology at second point, and so on. So in this way, I will simply say not the converge, I will only say the combination of multiple technologies. Those might be the one behind other, or might be the converged point of view kind of concept. So in this way, Industry 4.0 is there. So I hope you must have understood that what are the basic components and what are the functional definition of means a different functional definitions of Industry 4.0 or cyber physical systems. And hopefully you might have got the basic flavor that what you are supposed to get exposed to in future. In future, Industry 4.0 is supposed to become a reality, not today, but 20, 30, 40 years ahead. Definitely you will see this sort of magic that things are performing their work automatically, means they are learning by their mistakes, they are having user opinions automatically. Users are only playing, means users are only actively involved at application layer. Rest everything is supposed to get governed by machines only, sensors only. So in this way, that is the wonderful future that is supposed to come ahead. And hopefully you must have enjoyed this description. If not, then please let me know what are the drawbacks, and hopefully we'll meet in the next video. Thanks for watching this. Happy learning.